My name's Sarrabeth Stone. I'm a postdoctoral researcher at the Florey Institute of Neuroscience and Mental Health. So I spent 5 years in America in Minnesota at the University of Minnesota studying multiple sclerosis there as well. And then I was back home in New Zealand for a couple of months before moving to Australia. My mother was diagnosed with multiple sclerosis when I was about 9 years old, which was like a big change for our entire family. And so I sort of grew up watching the way that she had to deal with MS and had to, deal with doctors and, her onset of symptoms and how that impacted her and our whole family's life. It was really difficult to watch her go through that, especially because when she was diagnosed, it was really when the disease-modifying therapies were first coming through. So obviously it was extremely stressful for my parents when she was first diagnosed because they had no idea what was going to happen. So I was always sort of drawn to the idea of MS research. And then when I was at university, I had the great opportunity to work with my PhD advisor, Professor Anne LaFlamme at Victoria University in Wellington, and she was working on multiple sclerosis research. And so I was able to work in a lab, and I loved the immune system and I loved the brain. And so it was sort of like this perfect storm of all of these things that I cared about and interested me coming together. One of the things that we haven't really been able to treat yet is the progression of the disease. Even with well-controlled MS, there is still progression of the disease, and it's really important that we're able to understand the way in which the brain is able to repair itself and the ways in which we can promote that repair. And I think there's been a lot of work recently in understanding how the repair mechanisms of the brain work, and that's really where my research is focused, in wanting to be able to focus on repairing the brain, and that would reduce symptoms and improve the lives of people who have MS. My research project is focused on the cell of microglia, which is the immune cell in the central nervous system. So microglia are a really interesting cell because depending on the context in which they encounter inflammation, they can be pathological in multiple sclerosis, but they also can be protective, they can be reparative, and they're really important in the process of repairing the brain. But we don't know exactly how we can induce these microglia to become a protective cell type. And so my work is really focusing on finding the way to promote microglia to assist the brain in repairing the damage that occurs in multiple sclerosis. And to do this, I'm looking at a particular type of molecule. It's called microRNA. We call them like a molecular switch. They have the ability to control the phenotype of the way that it acts. They regulate the function of the cell. And so my lab has been investigating the microRNAs that control the identity and function of the microglia. The aim of the project is to identify the microRNAs that promote the microglia to become reparative, and to eventually develop these into a therapeutic that will promote remyelination and protection of the brain. It's my hope that this research will lead to the development of a treatment that will promote repair in the brains of MS patients and limit the progression of disability, especially in patients who have progressive MS, because they have far limited treatment options than people with relapsing remitting. But obviously I feel that this treatment would benefit everyone who has MS. And because this treatment isn't targeting the peripheral immune response like other treatments, it could potentially be used in tandem with some of the other disease-modifying therapies. So you have one branch of treatment which is controlling that immune response, and then you have another branch of treatment that is trying to repair the brain. And together, all of this could lead to a really effective treatment paradigm for MS.